Hello friends, now we will discuss about hydrogen bond, which is a very important concept of chemical bonding. Let us consider a polar molecule which contains hydrogen, say HF. A single covalent bond is present between hydrogen and fluorine. Now fluorine is highly electronegative, so a partial negative charge is developed over fluorine and a partial positive charge is developed over hydrogen. And there is another HF molecule. Same thing occur in HF. Hydrogen is positively polarized and fluorine is negatively polarized. So there is an attraction between fluorine and hydrogen because the negatively polarized fluoride ion attract positively polarized hydrogen, and these attraction, electrostatic attraction, is called hydrogen bond. Due to formation of this hydrogen bond, large number of HF molecules are associated with each other, and this can be written as HF whole N. So when an electronegative atom is linked with hydrogen by a covalent bond, then this electronegative atom form a weak electrostatic attraction with hydrogen of the same molecule or different molecules, and this unique electrostatic attraction between electronegative atom and hydrogen is called hydrogen bond. Now, what is the condition for formation of hydrogen bond? Conditions, this is very important. Conditions for formation of hydrogen bond. Number 1, the atom other than hydrogen must be highly electronegative. Number 2, the atom other than hydrogen must be very small. These are the two conditions for formation of hydrogen bond. There is a very popular question in exam, which is H2O is liquid but H2S is gas. Why? The answer is that size of oxygen is much smaller than sulfur, and electronegativity of oxygen is higher than sulfur. So, in water molecules, negative pole is generated on oxygen and positive pole is generated on hydrogen. So, the water molecules are associated with each other by hydrogen bond formation, like that. So, water can be represented like that, H2O whole N. That means N number of water molecules are associated with each other. But since sulfur is bigger than oxygen and its electronegativity is lower, H2S cannot form hydrogen bond and it exists as isolated single molecule. So, intermolecular force of attraction is low in case of H2S compared to H2O. Hence, boiling point of H2O is greater because intermolecular force of attraction is greater, and H2O is liquid at room temperature, whereas H2S is gas. Now, hydrogen bond is classified in two categories. Number one, intermolecular hydrogen bond, or it is called external hydrogen bond. And number two is intramolecular, or it is called internal hydrogen bond. In intermolecular hydrogen bond, two different molecules are associated with each other by hydrogen bond. Like that. In intermolecular hydrogen bond, two different molecules are associated with hydrogen bond. But in case of intramolecular hydrogen bond, the hydrogen bond is formed within a single molecule. Let us take an example of salicylic acid. Salicylic acid. In salicylic acid, OH group and OH group is polar and positive charge is developed over H plus and negative charge is developed over double bonded oxygen. So, attraction between O and H occur in this way, and this is represented by three dots. This is called internal or intramolecular hydrogen bond. The COH group and OH group present in the same molecule and they form hydrogen bond. So when hydrogen bond is formed within a single molecule, it is called intramolecular hydrogen bond. There is a very common question in exam. It is, Salicylic acid has lower boiling point than its para isomer. Why? The answer is that salicylic acid means 2-hydroxy benzoic acid or ortho-hydroxy benzoic acid. In 2-hydroxy benzoic acid, two polar groups, that is COOH and OH group, are in close approximation. Negative charge is developed over double bonded oxygen and hydrogen contain positive charge, so attraction between O and H take place. It is called intramolecular hydrogen bond, and the molecule exists as single isolated. It exists single and isolated. But in case of para isomer means 4-hydroxy benzoic acid. There is OH here. In para isomer, the COOH group and OH group are away from each other, so they cannot form intramolecular hydrogen bond. In salicylic acid, intramolecular hydrogen bond is present. Intramolecular hydrogen bond. But in its para isomer, the two polar groups are away from each other, so they cannot form intramolecular hydrogen bond. Two different molecules are associated with each other like that. They form intermolecular hydrogen bond like that. This is called intramolecular hydrogen bond, denoted by blue dots. Intermolecular hydrogen bond, and large number of para hydroxy benzoic acid, the para isomer of salicylic acid, are associated with each other. Intermolecular hydrogen bond, and since large number of molecules are associated, their boiling point is high, so para hydroxy benzoic acid has higher boiling point than salicylic acid, because salicylic acid exists as single molecule and para hydroxy benzoic acid exists as associated molecules. So intermolecular force of attraction is greater in case of para isomer and its boiling point is higher. That's all about hydrogen bond. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.